Hi, this is Craig with Authentic Battle Damage, and we're going to continue on our adventures in bit making. We're going to take the player X and player O binary int patterns, and we're going to use these as a way of setting the board. It's going to represent the board. So rather than representing the board with, say, a dictionary, we're going to represent it with integers using binary comparison patterns. It's going to be fun. Now, since player turn is representative of the player, and we also have an integer representative of the player, this is a good time to pull it out into its own class. So we'll call it class player. And what we can do then is we can create a constructor which will take in the name of the player, and we'll do this dot name equals name, and we'll generate a field for name, and we'll also override the toString method, and we will return the name. We can also then move the integer, we'll call it, what should we call it? For now, let's call it public int board. Yeah, that works for me. And then in here, when we create a new player, we will initialize the board to the blank board. Cool. So now that we have a player, we can then create in the model, we can create both of our players. So we'll call it public player X equals new player, and we'll give it X, and public player O equals new player O. Oh my. Then excuse me, public player turn equals null, because at the beginning we won't have a player. So now for these, we can get rid of these because now they're represented by the players themselves. Now, as you can see here, we're comparing this board, which is a string, to player turn. And to make sure that this still works, we can just change it to toString, and that'll still work for us. So let's just do that for now. We're going to be replacing this, but we want to make the incremental changes. Player turn equals, and then here we would do player O, and here we would do player X. All right, let's see if everything else looks good so far. Yep, it does. Let's just try it out with that one little change. Oh, we have an issue. Player turn dot equals. Oh. So we could also override the equals, but But yeah, let's not do that. So let's just change this right away. So switch players. What we can do is we can do if player turn equals null, or player turn equals player O. So they'll be comparing. Yep, this should work. Then we'll want to change it to player X. Else, if player turn... I know I'm switching these around. If player turn equals... If player turn equals player X, then we want it to be player O. Okay. A1. Yeah, so let's talk about what I just did there for a second, because so when the game first starts, player turn is null, and when it is, we want it to be player X's turn. Excuse me. So yeah, that's why I put in this. If the player turn is null, then we'll be turning it to player X. But so yeah, we switch these around a little bit, but you know, that's all good. But it works. So that's good. But now we have the board. So what is good about this is we can then start replacing the board with the binary pattern. So first of all, the board is going to represent, let's make that change right now. The board's going to represent something different. It's not going to have the a string represented anymore. We're going to have it represent an int. And so in here, we're going to have int location equals 0b1. This will be A1, 1, 2, 2, 3, 1, 2, 3. So that's going to be A1. And that in our for loop here, we're going to get A1 first, and then we will set this to location. Now, to move it to the next one, we'll do location equals location shift to the right by 1. Let's see what it's saying here. Use compound assignment. Why not? Okay. Yeah, so we're going to shift the location to the right 1. So that'll change this. It'll move this 1 to this location, and then to this location, and then to this location, all the way down for each of our things. So we'll put it int here. All right. And then to get owner, we can then string location, board location will then give us an int. And what we can do here then is to get the owner of, get owner is being used here in the view model.getOwner, and then we're going to pass in this, and so, and then so we're going to say what is in that location, who owns that location. So we'll first check player X. So we'll do if player X and board location equals board location Oh, sorry. Player X dot board. This should be working. Board, because board. Yeah, we get the string, and then it's going to return an int. The cannot be applied to operands of int and bool. Right. Yeah. But this is a Boolean check that we're doing. Oh, I just needed to put a parentheses around here. Cool. So if player X, so we're anding the board with the board at this location, and if it equals that location, then we can say string result equals nothing, and then we can return the result right here. Then we can do result equals player X dot toString. And then else if player O dot board and board location equals board location. Oops. Result equals player O dot toString. All right. So that made get owner look a little bit weird, but look at it, totally invalidated what we're doing here. Well, yeah, why? Oh, that's why. Because we changed board to an int. So not a problem. We're going to be changing all of this. So let's do that next. We're gonna go into here. So the first thing we want to do is we want to define our win states. So we can do private int, and we're going to make it an array. Win states equals new int, and then we will specify them all here. So the first one is going to be, let's copy this. We're going to have the top, the middle, the bottom, down the left side. Oh, darn it. Forgot to copy that. So we're going to have, okay, so top, middle, bottom, down the left, down the middle, down the right, from left diagonally to the right, from right diagonally to the left. Okay, so this first one is going to be the top, the middle, the bottom, and then we're going to have down the left, then we're going to have down the middle, and then down the right, and then the upper right, the middle, the upper left, and then we're going to have the lower left, the middle, and the bottom right. So here's all of our win states. So now what we can do is say, so we don't need this check anymore. We don't need this check anymore. Let's get rid of all these. And then we can get rid of these. Then what we can do is if player turn dot board and okay, so for each int state in win states, if player turn and state, we're gonna have to put this into a parentheses, equals state, player 1 equals true, and then we can do break. And here we can do player turn. See, that's actually, I think this will work, but player turn and state. Wait, okay, what's going on? Oh, player turn dot board. Okay, what's wrong?
What's wrong, Mike? What? The left side of the argument must be a variable property or indexer.
Player turn dot board. What? You have me confused. For each int state in win states, parentheses can be removed. Left-hand side of an assignment must be a variable. Oh, it's because I don't have equal equals. Darn it. Okay, equal equals. There. Boy. All right. Okay, so that should be it, and then this should make the toString get called. Cool. All right. So if board answer is blank, so okay, let's error, spot error, check for error, answer. So they're going to get an answer, and if board contains key, yes. And then we go, if there's nothing there, then we can then set it to the player. So what we're going to need to do here is we're going to need to return a board. So we'll call it private int get board, and we're going to return player x dot board or player o dot board. And that's going to return our whole board. And then here what we can do is we can say if get board if get board it's going to return the int, and then we're going to do an and player, no, answer. Oh, yeah. So we're going to get the board answer equals 0. I'll put this in a parentheses. All right, so we're going to get the board, and the board answer is going to be one of these locations in the dictionary. So that was created through here. So if the board is 0, then we know it's free. So then we can then set the board, or we can set the player to the board. So to do this, we're going to do player turn dot board equals, or maybe we should do a or equals board answer. And then there we go. So yeah, so if it isn't, we've got an error, and if they put in the wrong thing, we have an error, and then we return all that, and that's good. All right, last thing. Now we're looking for, do we have a draw? In fact, let's rename this to check for draw. Yeah, I like that better. So now we don't even have to search in here anymore. We can what we can do is check for draw. Empty spot found. So empty spot found equals true. And then empty spot found, check for draw. If empty spot found, so let's rename this draw condition. So if draw condition, so if it's true, so we're switching it. So then what we can do is we can do get board and B, no, 0 B 111 111 111. So we'll return get board equals so yeah, so okay. All right. Let's test this out and hopefully it'll work. A1. Okay. And then where's O going to go? B2. C1. And then O's like, oh my. I'm going to go to B1. And then X is like, oh yeah, well, I'm going to go to B3. And then O's like, I'm going to go to A2. Well, let's try A1. Yeah, we got an error. Okay, so O's like, okay, fine. I'm going to go to A2. And then X is going to just be dumb and go to C3. And then O's like, going to go in for the kill for C2. O wins. So that's good. That's the win state works. Let's try the draw. C1, A1, B2. Whoops, I did B3. B1. Let's now go to B2. I'm trying to go for a draw. I might accidentally win, which would not be good. Let's go to A3. And then A2. And then, yeah, C2. And then C3. And we should have a draw. We do. Great. So everything is working. So what's really cool is the only thing we changed in the controller was that we reversed the check here. And then in fact, what I want to do is I want to inline this here. Get rid of that variable. And we didn't change anything in the view. And we did most of all of our changes in the model, and we created a player, and the view doesn't know anything about the player. It doesn't know, and also the controller doesn't know anything about the player. So one really good thing, a question to ask yourself, Now, after you have put a application out into the wild, a question to ask yourself is, if you're going to make a change to a system, how many classes need to recompile? Technically, the controller class had to recompile because of our change and the model. But most of everything happened in the model. And, again, this is not really a huge... There's no real reason for doing this. I mean, tic-tac-toe is a simple game. But what I'm really trying to show here is the fact that after, I think, the third or fourth episode, the game was done, and it was all procedural, right? In fact, here, let me pull up what the original looked like. Got it here somewhere. Don't know where. Maybe I don't. Well, I'm gonna have to find a copy of it. Well, because I have it actually here in Git, because I saved it. But we can look at like the difference between the two, and we'll do that in another episode. We're getting very close to moving this stuff over to Unity. And what's really cool is I'm going to be taking the model. I'm not going to need the view. In fact, let me see how long we've been hanging out here. 26 minutes. Yeah, let's put an end to this, and let's refactor some of this stuff out so that we don't yeah, maybe it doesn't matter, but I really don't want to have certain text in here, because we're not going to need the view in Unity. Unity will be our view. And then I think that, we could, my hope is that we don't change things at all. And so it's going to be kind of cool. We're going to take our model and our view and our controller, and you're going to see how we're going to plug it right into Unity, and then we'll make our visual changes in Unity. And my hope is that the game will then work. And of course, we're going to be changing the controller over to more the way Unity works. We're not going to be using this while loop. Though technically, I think we could. Yeah. Anyway, good stuff. Awesome. Talk to you later.